the other side of the country. The other ocean looks very different than here, and if you ever get a chance, I highly recommend that you go because it's worth seeing how the two different oceans can contrast, even though they're both part of the same global body of water. So basically, travel around the world. When we go outside of what we know, when we go to new places, we get to learn a lot about the world outside of us, and we also get to learn a lot about the world inside of us. So we learn about nature. You can see there's beautiful cliffs and oceans and everything and flowers, and just the chance to actually get out there and feel it for yourself tells you a lot about it that's different than what you learn in books, but that complements what you learn in books. And also become a better person. I feel like when you go and do different things in new places, it helps you to grow as a person. Has anybody here kind of left this area? Has anybody traveled to other countries yet? Oh, a lot of people here have had a chance to travel. That's pretty lucky. Where have you guys gone? Mexico? Yeah.
Australia.
Australia, well, you?
I think I've been to two.
Pardon?
I've been to two.
Which two?
Canada and like Virginia.
Okay, and one more. Where have you been? United Kingdom. Oh, wow. So you guys have had a chance to travel a lot. Not everybody is fortunate enough to do that. So it sounds like you guys will have a lot to connect with, because I think that there's a universal experience when we go to a new place and realize that other cultures and geographies are different than what we do. So let's move on. Passion and reason. These are two of the kind of driving forces. So when we talk about why we would go and do other things, like why people do science, why would somebody go and do an experiment to learn something new? Passion and reason kind of combined together. And this applies both for you in your own lives and also in the bigger picture of when people get together to conduct a big research project and learn about the world outside. So you can do what you dream of doing. You guys all probably have ideas of what you want to do as when you grow up, and either for work or for travel or other things. And basically a lot of that is possible. We live in this incredible world that we're fortunate to have so many possibilities. So just, if you have ideas, then I encourage you to go out there and try stuff and just have fun while you're improving and learning. So here's a little bit me, like I told you, write about science, riding, running, bicycle. The big science topic I write about is, who wants to guess what this is? Yeah.
Satellite.
A satellite, that's a great guess. Yeah.
It's like that you can connect with space.
You can connect with space with?
Like the satellite in space, like.
Oh, like the satellites in space, you can connect and keep that up? Okay, yeah.
Is it for like the
Wi-Fi? Okay, so everybody's guessing a satellite, and it's the exact same technology as a satellite, but what would happen if you took a satellite and instead of just collecting a signal that somebody else is sending from a satellite or from some other antenna, what if you just opened it up and looked at the sky all around? Then you would see basically a huge area of space. So you can use, it's basically like an antenna for picking up a radio signal or a TV signal or Wi-Fi internet, but instead scientists will use this as a telescope and look at all the stars. So who here knows how a telescope works? You do.
My cousin has one, and I use it. We used it last summer, and we saw Mars.
Cool, but this probably doesn't look like your cousin's telescope, does it?
Nope.
Okay, anybody want to offer an explanation of how a telescope works? Yeah.
The telescope is like, it helps you to see farther, to see different things that you can't see with your own eyes.
Okay, that's what a telescope does. Now let's talk about how a telescope does it. Do you have an idea of how a telescope helps you see things that you would not ordinarily be able to see? No? Do you have an answer?
Me?
Yeah. Yeah, your hand up.
It's maybe the telescope works that you have to put your eye in this hole and you, I don't know how to explain it.
Okay, you?
I think the telescope works like glasses. When it's like it makes you see like in space when you put your eye in the little hole.
Okay, so that's as close as we've got to the mechanism. So a telescope works kind of like glasses. So I'm wearing glasses. They help me see farther than I would without glasses. So basically, it's kind of the same idea. A telescope usually takes a lens And so, like, these are big lenses, bigger than a regular eye, and it collects a lot of light, and then brings it all that light together into a thing that you can look through or record, so you can see a bigger, clearer picture. So a telescope like this does the same thing, except instead of with light, it does it with radio. So just like you have a radio that collects like music from the radio signals, you can collect all the radio that's coming from space. So space is actually full of all kinds of radio signals. You know, we normally think radio is just around Earth, but if you look out at the big galaxy all around us, it's actually full of all kinds of radio signals all the time. So let's keep going and see what else people have done. Here's another kind of telescope. So the radio telescope looked like one thing. This looks like a totally different thing, but it's also a telescope. It does the same thing, but with a different technology. So here, instead of a radio dish, it's basically a spinning pool of liquid mercury. Anybody played with liquid mercury? Yeah, you have? What's it like?
It's like liquid mercury is like weird kind of. It's like when you like use it like spins around. And then I've seen like one of those before, and then it was like spinning, and then like the liquid was like going.
Right. So liquid mercury, it's like a metal, but usually a metal. You think of a metal, and I guess there's not too many metal objects around here. But usually metal is like a big stiff thing, right? Metal is like a heavy pole that you can't really bend or break or do anything with. But mercury at room temperature is a liquid, so you can spin it around, and if you spin it around in the right speed, then you can make it into the same shape as a mirror. So basically, the idea here, the idea of the experiment, we talked about science as an experiment. The astronomy, the study of space, it's all about different kinds of experiments where you collect a lot of light by bouncing it off a mirror or an antenna or something, and then you collect it. So that's kind of a little bit about how that works. There's all kinds of different ways of doing, of looking at these things. I guess the point here is that, you know, when we look out at space, it's pretty surprising, right? Like, we're all here, we all live kind of in our everyday lives, and we kind of see just the things around us, right? Like, you know, we don't necessarily think of space. If you look up at the night sky, you know, what do you see? You see a bunch of stars, right? And you would usually just have a pretty basic view. But if we look at these, we actually see something completely different. So normally we think, you know, it's pretty ordinary stuff every day. But actually, out there, if you look through a telescope, you realize that we live in this remarkable place where there's all kinds of stars and galaxies. There's a huge world out there, and Earth is just one tiny part of it. And we're, you know, we have so much more that we can see. So, who here else has looked through a telescope? You have. What have you seen? Stars. Yeah. Uh-huh. Yeah, you have? You saw what? A blimp? Pardon?
A planet.
A planet? Oh, cool. Yeah, you can see planets. If you look through a telescope, you can see planets. If you don't have a telescope, it just looks like a star. But when you look through a telescope, it looks a little bit more like the actual planet. Yeah?
It's when you look up the sky and see like stars, but they're actually like huge balls. But we're so far away that they look like stars, but they're like shaped as big yellow balls that are like they're full of heat.
Right. Exactly. Like if you just look up on the night, you just see a little dot of light. But if you could actually see it up close, you would see this really complex thing with all this light and different layers, and it's a huge complex thing. It's really beautiful. Yes. Okay. Did you have your hand up? There's somebody over here. So yeah, I mean, I guess that's a big message. It's the same with us, you know. If you look out at the stars on an ordinary night, it can be really beautiful. But when you actually kind of study it carefully, you realize that it's a lot more than that. There's a lot more depth there. And the same is true of us. I mean, normally, you know, we just see like who we are. It's easy to just think of ourselves as like who we are from one day to another. But really underneath that, you know, there's a lot more that we can do. If you actually, you know, study ourselves carefully, we realize that we have a lot of possibilities that are kind of latent, which is a fancy word to say hidden underneath the surface. So we can do all kinds of cool things. So there's robot telescopes, telescopes that kind of do their own thing without any human control. This is, to me, the most interesting one, but it's not the really easiest to see. So who knows what the most powerful telescope is in the world? Nobody. So it's actually not a device, it's actually the human brain, because a human mind, if you look at like the theory side of things, people can just use their imagination to come up with things that are light years and light years away. Does anybody know how far a light year is? No? Anybody want to take a guess? Yeah. A million miles, okay. A trillion years. Yeah.
Over a million years.
A million years, yeah. 100 million years. Okay, so we actually have two different, yeah.
No, 100 trillion years.
100 trillion years. Oh, you have one?
10,000 miles away.
10,000 miles away. So we had two different kinds of answers actually. It's kind of a complicated word because it says light years. So it sounds like it's kind of a period of time because of years, but it's actually a distance. So it's more like a mile instead of an hour as far as measurement. And basically it's a distance that light travels in 1 year. So light travels at around 300 million meters per second, which is extremely fast. And so if you multiply that by a full year, then you can imagine just how many trillions and trillions of miles that would be. It's a really long way away. And that's just 1 light year. So imagine one little human brain that fits in, a cubic foot is able to conceive of all these stars that are happening light years away. And that's a lot more impressive than any piece of equipment that can look at the stars. There's also, along the way, this is in the Mojave Desert. Who knows where the Mojave Desert is? Yeah. Yeah.
Australia?
Australia? No.
Mexico?
Mexico, not quite, although I guess it changes name. It's part of the same desert as one that's in Mexico. Yeah.
Texas?
Texas, no, of course. So it's after, yeah.
Where's Miss Shelton and Mr. Armstrong from?
Pardon? California, there we go. Okay, yeah, so this is in California. And when I was in California, do you have a question? Oh, okay. So in California, there's this thing called the Mojave Air and Spaceport, which is actually a really amazing facility. It's a place where they're launching spaceships, and so I went here and met some people, and basically you can see the spaceships. I don't know if there's many in this shot, but you can just walk around the area, and now they're building more and more spaceships. So maybe in 10 or 15 years, like when you guys are kind of, young adults and looking for jobs and stuff, maybe they'll have like, space flights in the same way that nowadays people go on airplanes. So they're starting to develop a lot of research. And basically, a lot of that research into what's out there in space that's really theoretical, it also has practical applications because when people learn what's out there, they also discover new ways to make spaceships so that we can get to those cool places. So they do it for television. Here's a beautiful shot. This is the kind of thing you can't really see through a backyard telescope, but if you look through those gigantic telescopes, you see that the universe is full of amazing things. This is like many, many, many light years across of huge, beautiful clouds and stars, and there's all kinds of really brilliant things happening everywhere. The Vatican telescope. Anybody know what the Vatican is? Yeah?
The Vatican telescope?
What is it?
It's I don't know, what can I guess?
Yeah.
Is it like a big telescope that like can see from miles away?
That's what the Vatican telescope is. Yeah.
Is it like a telescope that helps you see farther than a normal star?
Yeah, so okay, the Vatican's an organization that's like basically a big organization that operates telescope. They're one of the first groups to develop telescopes hundreds of years ago, and now they have a new telescope. This is in Arizona. Usually Arizona we think of kind of like the desert, but this is a different part of Arizona. And they kind of are looking out there to see what is our star like. So our star is the sun, right? you talked about how stars are just like a big ball of fire. Well, the sun is a star too. So we're like living on this rock that's kind of floating around a gigantic ball of fire, and they're kind of curious to see what is it like, you know, is there anything special about our star, or does it look like the other stars from far away, or what kind of picture would you have if we could look at our own planet and star through a telescope? Okay, the next part, so that's the end of the sort of science part, like the direct, like just looking at telescopes part. But science can also be kind of more entertaining. So I think a lot of these ideas can seem super far away if you're just looking at those pictures of telescopes. But I think it's important to realize that they actually, it's kind of relevant to us, and it should be